basically the setup here is, people have been talking a lot about things like customer loyalty, about reliability at the data level and at the marketing level. And if you think about, so the way that I think about cannabis, so like when I came into the space, on the one hand, you have the sort of mental model that is still the mental model that most people have at the consumer level today. And this is the model, right? You've got purple ones and you've got red ones. The purple ones make you sleepy. The red ones make you energized. And what this is, right? It's a very simple map. It's a very simple schema that anyone, no matter what their education level is or experience level is, can use to try and understand something that's really complicated, right? So this product, the base product here, is really a cocktail of many different drugs. These drugs obviously have psychoactive effects that are really difficult to talk about. It's hard to know what someone means when they describe the effects they're looking for they have, because people don't use language in the same way to describe that type of stuff. So this is the simple model that's in everyone's head. And sort of when I came into the space from my background, I really thought of it in a chemistry forward way. So I came to Leafly, if we go to the next slide, and Leafly's, one of Leafly's initial claims to fame was its strain database, right? So you've got these three broad categories of cannabis flower: indica, hybrid, and sativa. And you've got allegedly thousands of allegedly unique strains out there, which can each cause unique effects. And, Leafly came up with this poster, this is a decade ago now. It was really cool because, again, it's the same concept. You're simplifying something that's really complicated. Instead of having to memorize 100 different strain names or 1,000 different strain names, you can just know red, green, purple. And, they came up with the so-called periodic table of strains. And the idea is, just like in chemistry, there's sort of a logic by which you can map out all of the elements in a very structured and orderly way. Maybe something like that is true for cannabis too, because as consumers, we know it's not all the same, right? You don't get the same experience every single time you smoke weed. There's something interesting going on there. I can think back to my high school days, and it didn't always hit me the same. And we would come up with folklore practically in real time, right? Some of my friends would say, oh, it's the ones with the red hairs. Those are the best ones. Other people would say, no, it's the ones with the crystals. No one had data, right? It's easy to forget that today. No one could actually systematically understand these things. And so people come up with whatever they can based on the experience they have, the sensory attributes of the product and so forth. So next slide. But basically, the problem is actually quite simple conceptually. If you actually want to understand what these drug cocktails are doing, and if there are differences between them, you got to know what the drug cocktail is, right? And so I came into the space and I thought, wow, cannabis is legal now. All of these products have to get tested. We can just go into the labs, do some fairly basic analysis, and understand what's inside these plants. This is high magnification microscopy image of trichomes, and right, so these are secretory cells that release the drugs that are going to drive whatever the effects are that a consumer is going to get. So the idea is you just go in, measure all of those things, do some simple analysis, and then you can understand everything. It was a little bit harder than that. Next slide. But right, we want measurements of all of these things. And we want to understand, go to the next slide. Right, if this is true, if there's different types of cannabis that have systematically different effects on average, something like this has to be the case, right? So if there are sleepy ones and energizing ones, what that means is there's going to be a different ratio of all of these compounds in it, right? So we just go in, we can measure all of these things, we can see what the labels are on the product, and we can just ask, what is the difference between an indica and a sativa? Next slide. So long story short, I had to do a lot of work to get my hands on lab data. And, on the subject of data cleanliness, which has come up a number of times, it's very important because garbage in, garbage out. And you can't trust the data from all the labs. We have published some research on this with some colleagues back east. You can go look at that in detail. And if you've been in the industry at all, we sort of openly know this dirty secret about the labs. The numbers are not all trustworthy. But I developed some statistical tools to allow us to vet labs. And then next slide, we partner selectively with various labs throughout North America. Long story short, there's a vetting process that happens. I ingest their data, we analyze it, and then we decide whether or not to work with them. And the answer is no about 3 out of every 4 times. We look at their data, there's quarterly audits, and then they give that data to us in a particular format. And once we have all of that data, I'm summarizing about 2 or 3 years in a minute here, you can actually go in and answer the questions that I was talking about with respect to the chemistry. So next slide.
Did you do site visits?
What's this?
Did you do site visits or just
Just look at the data. There's no need to do site visits, actually. If you just look at the data, there's some backup slides at the end I can show you. It's actually trivially easy to see who's cheating. Yeah. So anyways, once we have the data set that we trust, I worked with another group out of the University of Colorado and a former data scientist at Leafly to actually map out the chemical landscape of cannabis flower in North America. What are all of the chemical phenotypes that we see in cannabis? And how does that objectively defined, algorithmically segmented chemical landscape, which I'll show you a preview of, how does that map onto the consumer, the market, the labels on the products that these products are marketed with? Next slide. Okay, so long story short, that paper's online, you can go read it, but we do data stuff, right? So you just take a matrix of all of this chemistry data and we run it through things like clustering algorithms. And what we find is that for THC dominant flower, which is going to be about 97, 98% of the flower market in the United States, we can define clearly 3 super clusters of cannabis strains. In other words, there are 3 reliably present, statistically distinct populations of strains based on their chemistry, present anywhere that you look. Any geography you look at, you're going to see the same basic breakdown. And they're all characterized by having a different terpene profile, right? And I'll show you briefly what that is, and then we'll talk about strains. So let's go to the next slide. So what do I have after this? Yeah, let's start here. So this is one chemical phenotype that you see reliably in the space. It's characterized by particularly high levels of this thing called caryophyllene and limonene with some other stuff. Details don't matter. Don't worry about it if you're not familiar with this stuff. But certain strains statistically are overrepresented as having this phenotype. And there's a lot of them. In fact, this is around 60% of all cannabis flower you've ever smoked. This is what you smoked. All the glues, things like Gorilla Glue 4, the cakes, the cookies, the gelatos, things with those types of names tend to be overrepresented in this group. So like the brand cookies, they're one of the most popular brands out there. They have new strains every quarter, every year. There's always a hot new strain. All of their strains are basically just this. So there's a little bit of variation there, but a lot of the stuff that's out there, there's 1,000 different strain names, but there's really just a few types of weed. Go to the next one. This is the second most prominent chemotype, chemical phenotype you see out there, particularly high levels of myrcene with pinene, right? So it's a different terpene profile, different relative ratio of the drugs inside of these things. Certain strains are tied to this one. If you go to the next one, this one is in the minority. Only about 1 in 10 strains will have this chemotype. It's a little bit more interesting and exotic in different ways. It has really high levels of this thing called terpinolene. And you'll get certain strains here. You can see some of them there. But if we back up, apologies, go back to slide 12 now. If we, I'm going to tell you how I think about it, and then I'll make it a little bit more concrete and user friendly. So this is just a map of the chemistry of commercial cannabis. This is how a computer sees it. The 3 different colors you see here are our algorithmically defined chemotypes. So they're statistically distinct chemical entities. And what we've done here is we've just, think of this like a map of the neighborhood. And now we want to see like where all the stores or where all the products are or something. So, you've got black triangles and diamonds here, and those just represent individual samples of products made by God knows who. And we don't know what it actually is. There's no genetic testing. We have no idea what it really is, but we know what the chemistry is. And we know that the producer is choosing to call it either White Tahoe cookies, these samples, or Pineapple Express, these samples. And what I want you to see here is that for the black triangles, that's White Tahoe cookies from all different regions, from all different producers. We have no idea if they're using, the same genetics or anything. But notice that they're not all in one point, right? So if this was a map of the ingredients of soda in the United States, every can of Coke right on that table back there would be right on the same spot on the map because it always has the same ingredient list. So notice for White Tahoe cookies, they're spread out a little bit, but they're all in this neighborhood, right? So 9 times out of 10, it has that high caryophyllene profile, and there's some variation there, right? Some people grow indoors, outdoors, et cetera. But notice Pineapple Express here. It's a very different story. It's all over the place, right? So in other words, if you close your eyes and you pick a random strain off a shelf and you do that twice, that's going to be just like going and buying 2 different brands that have Pineapple Express on the label, right? It's a random distribution of chemistry. Go forward now. So like, how do you turn, if you turn that data, so like in my head, how do I think about that in terms of like a more user-friendly way to think about this? Well, if we play this video here and we just sort of think about the Leafly periodic table of strains, right? It just used to be purple, green, red. If we play this, essentially what I'm showing you in the data that you just saw is, here we go. Is okay, let's look at this chemistry forward. Let's change the colors to represent the chemistry rather than the cultural labels. And it's a mess, right? The colors are all over the place. But if you just rearrange these things based on the chemistry rather than sorting them based on the labels, you can see there's actually a very orderly map that you can draw here, right? And these are approximately proportional to what the data actually shows. And the point of this is there's just a handful of types of weed out there, right? There aren't 1,000 unique types of strains out there. There's just a few, and people are basically just making them over and over again and then rebranding them and renaming them and so forth. So if we go to the next slide, what I started to tell you is, these strain names aren't perfectly reliable. So I showed you the White Tahoe cookies example. I showed you the Pineapple Express example. We can analyze this systematically for every strain name that we have in the database. Go to the next slide. I'm not going to break this down too much, but the way this works is this line here, you see this dotted line, that's randomness. So if you see a bubble above the line, these ones with the stars, those are strain names which are statistically reliable, meaning you have better than chance odds that if you pick up two things named, say, White Tahoe cookies from two different brands on two different shelves somewhere, odds are pretty good that even though it's two different growers making it for two different companies, they're actually going to have the same basic profile. It's not going to be identical, but it's going to be that high caryophyllene, high limonene profile. And that's not true for all strains. Some strains are no better than just random picking. Let's speed it up. I'll go to the next one.
Is that about like 25, 30%, you would say, that are accurate, or?
We'll come back to that. Okay, so what does this mean for consumers? So again, what does a consumer want? They want a certain experience, whether they're a medical patient or a recreational consumer, they want a certain type of experience. And this is obviously common sense. But when you buy something, you want to know it's going to be the same next time, right? I don't want to pick up that can of Coke and sometimes it's Pepsi. So we want to bring consistency to the consumer experience. I don't need to belabor that too much. Go to the next. This is what I was telling you guys. So like if you go to the Coke, go to the first one, right? Basic stuff. If I go pick up a can in the back, my expectations match reality. It's always going to be Coke. It's going to have exactly the amount of high fructose corn syrup they're putting in it every time. For cannabis, it's sort of like, go to the one before this. Like if soda behaved like cannabis, it would be more like this. Where like, yeah, maybe 3 out of every 6 times the Coke is that. But sometimes I want to get Pepsi, sometimes I can get Sprite. It's kind of hard to know what I'm going to get. So if you go to the next slide, right, that's kind of the reality with cannabis. You buy Pineapple Express, you go buy it somewhere else. Maybe you're visiting a new state. You buy the strain name that you're familiar with, the mental model you've been trained to have as the consumer. But in reality, you could be getting any one of these things. Keep going. Okay, so a couple of things that we do at Leafly with some of this work, one for brands and cultivators, one for the consumers, just to give you a sense of what I do. Go to the next one. What we got? Got a lot of data at Leafly and we use all of it. Okay, go to the next one. One of the things we can do is we can build new recommendation engines. So one of the academic partnerships I have is with Computer Science Group at the University of Colorado. And so we're working with them to take all of these data streams and put them together in ways that allow us to do new recommendations. Won't go into detail there. Next slide. We can build markers and test just very simple stuff in our UX to see how it resonates with consumers. So for example, if you go onto Leafly today, you've got a strain page, right? Pineapple Express, White Tahoe cookies, your nug shot, your average THC percentage, with the most common flavor people report in the reviews, the top effect, et cetera, et cetera. And you got your 5-star rating, right? People say on 1 to 5 stars, how good is the strain? Spoiler alert, they're all about 4.5. Most weed is pretty good, it turns out. But we can build simple things to see if we can give people an indication of reliability or consistency, right? So maybe something like Pineapple Express, it's a 4.4 on average across all of the things called Pineapple Express that people reviewed, but maybe it's only a 1 out of 5 in terms of consistency. Maybe something like White Tahoe cookies is a 4.6 on a consistency scale. And so, A/B testing some of these markers and see how you always check for 2 things when you do A/B testing, in my experience. One, is the consumer going to interpret what you think they're going to interpret the way that you expect them to when you design something? Sometimes the answer is yes, sometimes it's no. And if they do, do they give a shit? Sometimes they don't actually care. Like, are people going to care about whether or not the strain they have is consistent and reliable or not? We have some reason to believe they will, but that's one of the things that we are testing right now. So go to the next one. So for brands, the interesting project that fell into my lap earlier this year, we had a brand from California come to us. They said, we're new, we're not even, nothing's on shelves yet, but they had made some new strains, right? They made some crosses, and they want to know, how do we market these things? What kind of effects are they going to have? They're not in the leafly strain database because we just created these things. We don't know what they do yet. It would be convenient if I could just use the data to tell them what it would be based on the COA, the profile it has. Gave them different strains that people didn't know what they were. They tested it, and they were smart, so we had to validate our data against that. But long story short, I could take their COA, match it up to our data sets, and then see what are the most common effects that I would expect to see based on all the leafly data. And it actually matched their consumer testing quite nicely, better than I expected, frankly. And so go to the next one. So that's one thing. Another sort of B2B application that we're building out is, if you're a brand and you've got a new strain, you're a cultivator, you got a new strain, you want to know what it's going to do, what it's going to be like, how you might want to market it. We can just take your COA. You can put in just a few simple numbers from that COA. We can, put it into our data stream, and you'll get out something like this. These are popular strains, similar in effects and profile to what yours we expect to be. These are the top effects we expect your product to have based on lining it up to what's in our database, and so on and so forth, right? So it's a sort of a predictive tool for brands. And this stuff I went through very quickly. There's videos and other content through different modalities about a lot of that stuff online through those links, and we have time for questions. Yeah.
So yeah, just going back to the first one. So if there's essentially 5 to 6 different types of kind of real strains that are out there, and then just infinite variations of names, it feels kind of like wine, right? In that sense, where there's cab and all that. Tempranillo and so forth. Do you essentially agree with that?
Yes. The short answer is yes. So go back the crazy Rorschach plot. No, keep going up. This one. Yeah, so this is basically what you're seeing here. So you've got 3 clusters here, 3 broad categories. So this, and one thing I forgot to mention is, if I were to just color code this red, green, purple for indica sativa hybrid, the thinking was, okay, we found 3 clusters. Oh, maybe we just sort of rediscovered indica sativa hybrid, and let's see which one's which. And the answer is they aren't. So the colors would not segment cleanly there. That's mostly a true statement. There's a little bit of nuance there, but you've got 3 types. But the actual chemically defined types don't map onto indica sativa hybrid. So this is like your analog of your Pinot Noir versus Pinot Grigio or something like that. And of course, with clustering, you could sub cluster these more and break them down more and more finely. But these are the 3 big ones that reliably show up everywhere. Like this neighborhood is a little bit different than this blue neighborhood, but it really is sort of 3 super categories that you might choose to break down into 2 or 3 more each. But yeah, like you said, it's, everything is really, anything that you see out there is going to be one of these.
So the last quick follow-up, and then I'll be done, is, you mentioned that there's a little bit of change in terms of the terpene profiles that are being generated here. And what's exciting based on what you're saying is, like, yes, sativa indica is certainly a genetic trait of these plants, right? But
no,
it's not.
No.
Okay, right. So that's my question. How much of this is environmental or food?
Yeah, it's a good question. So we can't answer that with the data sets we have directly, but those answers are out there to some extent. So we have no idea what are the grow conditions, what are the lights, is it indoor versus outdoor. What's kind of remarkable, so like all of these white Tahoe cookie samples here, I have no idea what their light intensities are, if it's indoor, outdoor, or whatever. It's across 6 or 7 different states, right? It's going to be very different grow conditions. Despite all of that variation, and despite the fact that they can name it whatever the hell they want, all I have is what they choose to call it. All of those samples, 9 times out of 10, are in the same neighborhood. So that starts to constrain your thinking there a little bit, right? Because it's saying, despite all the environmental variation that is presumably embedded in that data set, these points are not spread out everywhere. They're in one neighborhood. Now, of course, that's not the same with Pineapple Express. The more specific answer to your question is, this has been analyzed a little bit, and there is environmental components to this. So they recently compared indoor versus outdoor, and there were effects on the terpene profiles. It was mostly an effect of magnitude, how much each terpene was present. So I think what you would get under different grow conditions is, if you get movement within a neighborhood, but genetically speaking, this thing is like it's a caryophyllene limiting plant.
Right.
You can modulate it a little bit, but you're never going to jump something from here to here using a different light or something. Yeah.
A lot of the, I guess my understanding is a lot of the children we've got science that we understand for inhalation is different as it relates to like sciences.
Yeah.
Can you speak to that a little bit, whether or not
Yeah.
God is actually processing those?
Yeah. So there's one particular terpene where there's like some specific data on that is beta caryophyllene. Beta caryophyllene is unique among the terpenes. It's the only one that's also a cannabinoid, activates CB2 receptor. It's anti-inflammatory. What we know is it's actually orally active. So you can eat it and it'll bind to CB2 receptors in your body, just like you would if you inhaled it. Beyond that, I don't know. I don't know if there's any specific testing there. Certainly what's going to be the case is the bioavailability is going to be different. Almost certainly it's going to be higher for inhalation for any of these compounds than an oral route, just like cannabinoids like THC. And depending on your consumption method, if you're combusting it in particular, you're going to change the chemistry actually. So the effective drug is not what's in the box, it's what's in your bloodstream. So if you eat something versus vaporize it at one temperature versus light it on fire, the effective drug you're consuming is different in each case.
Quick question. Thank you, by the way, this is epic. I'm curious, so you kind of led us into thinking about calm versus energetic.
Yeah.
And then we kind of went into terpene profile and
how do we map that
variability of
Yeah.
terpene profile and so forth.
How do the effects map to
I'm
this?
wanting to hear like what are how
I'll give you
any reliable
I'll give you my answer to this, my personal answer. This is not like proven. So I go, of course I looked. I said, I have this map. How does the leafly effects data, if I was to make a thing that went from energizing to calming, where would I put
like
it?
paranoid and like whatever.
So I lied a little bit to you. So if you take on average, take all the indicas, all the sativas, you average them together, you say, what is the difference? The answer is there's no difference on average. But there's a lot of things we're averaging together. If you analyze these cluster by cluster, what you get is no difference between indica sativa hybrid in this one, no difference in this one. In this group over here, notice it's also further away. It's kind of interesting. And the reason it's orange is you have an overrepresentation of things that are traditionally called sativas or sativa dominant hybrids in this group specifically, and an underrepresentation of things that are typically called indicas. And in particular, if you go down to this one right here, 15, it's certain specific lineages of the things that are like sativa-ish. So all of the Jacks, Jack Rare, Black Jack, XJ13, lemon hazes, super lemon haze, ghost train haze, not all the other hazes. The Goldens, golden goat, golden pineapple, those things. So to partly answer your question, Adam, if we go back to the map here, my gut instinct from interpreting all of this is what you're seeing here is maybe there was something kind of like the more calming ones and the energizing ones, but over time through hybridization stuff, those lines got blurred. I wonder if this profile here is like the concept of a sativa, something that's a little bit more energizing. I have no specific evidence for that. It's just my instinct. And then this giant mass of stuff down here, it'd be like indicas and hybrids, which is most of what's out there, right? 75% of all the flowers out there is going to be one of these two actually. And we know that people do gravitate away from the sativas more and more towards the indicas and hybrids on average, just in terms of the purchasing patterns. That's the best answer I can give you.
Dude, thank you so much. That's great.
One question from Zoom. In the vein of predicting effects, do you see value and/or are you actively working on prescribing types of cannabis based on different body metrics and medical conditions from person to person?
Great. I would love to be able to do this, but no, we're not doing that. I would need think of all of the data that you would need to do that. Quite an undertaking. Yeah.
Kind of two-part. And thank you for the presentation. Really cool stuff. And I think a lot more of that type of analysis is definitely needed.
Yeah.
First question, like with this clustering analysis, because it's quite a strong message that there's maybe just these three main groups, right? But like clustering is also kind of a subjective technique in terms of how many clusters you choose and the parameters. So, could you speak to how robust you feel that conclusion is? And then second is kind of more about that variation. Like if you build a cookies guide, like, oh, hey, dude, all your strains are the same, they're gonna fight back and say,
Yeah.
oh, there's all these differences.
Yeah, there's, yeah, so,
Is there
yeah.
any indication of
Yeah.
interactive?
Yeah, so the answer to your first question is it's very robust because if you look at completely independent data sets from different labs, different, but they're all using different instruments and they have different people working completely different populations of cannabis, you see the same structure everywhere. And it's robust. And there's things that you can do to figure out like a good number of clusters, right? 3 is conservative here. We could split these more, but these are the 3 that you always see everywhere very reliably in these proportions. And the fact that we see them in all places tells you it's it's not dependent on a particular sample population. To your second question, yeah, so the overall profile is not going to differ as much as people like to think between these strains. That doesn't mean that there could be, say, a single terpene that's not present as high levels as these ones, the ones I'm plotting for you, but maybe it is particularly odorous. And having a little bit more of that one, you can smell the difference, even though it's not going to affect the overall profile too much. Something like that could be true. To the extent to which it's true, I don't know. Yeah.
Curious, you touched on it a little bit in terms of the form factor or the form of consumption.
Yeah.
Can affect the outcome. And for my personal experience, it's quite impactful.
Yeah.
In terms of the outcomes and the effects. Can you talk a little bit about that as to?
Yeah. There's 2 or 3 reasons for that. One is bioavailability, right? So you could take the same dose of the exact same thing and you're not going to absorb as many of those molecules through your stomach that you are if it goes right into your lungs and into your bloodstream. On top of that, you've got the specific, even for inhalational products only, right? You could vaporize at 150 degrees, at 200 degrees, you can combust it. You're going to get all of these compounds at different vaporization points, right? So even if you go from 150 to 200, some of them are going to vaporize, some of them aren't at different rates. So the effective drug you're ingesting is different. And then combustion, you're really going to change it. You're literally going to melt some of these compounds. They're going to turn into other things. And so that's going to be very different. And then, the way, especially when you think about the difference between, say, an edible and an inhaled thing, the reason, people always talk about the edibles nightmares that we've all had is first pass metabolism can change some of these drugs, right? So the classic example is THC gets metabolized into 11-hydroxy-THC, and it's got different pharmacokinetic properties. Yeah. Out of time. Okay, we're done.